So we're going to take a look at solving absolute value equations, okay? And what's really important with absolute value equations is that we understand absolute value really just means the distance away. And when we're talking about the distance away, we're talking about the distance from 0. We're going to treat this absolute value of x as if it were one big variable. So we're going to try to isolate it. So we'll add the 3, and then I get that absolute value of x is equal to 11. So my goal here is to try to change this problem so that instead of absolute value of x, I just have x. I want to get rid of the absolute value bars. Well, going back and remembering distance from 0, this is saying the distance that x is from 0 is equal 11. Okay? Well, just thinking about that for a second, if the distance that x is from 0 is 11, then that means that x could either be at positive 11 or at negative 11, because both of those values are 11 away from 0. Now, in this case, the absolute value is already isolated, okay? And this is saying that the distance that x minus 5 is from 0 is 3. So, a quick trick that a lot of students take advantage of is, in order to get rid of the absolute value bars, we could write the equation two different times. One where the absolute value is equal to a positive value, and one where the absolute value is equal to a negative value. In other words, we could be at positive 3 or we could be at negative 3, because either way we're 3 away from 0. So I'm going to add the 5, so x is 8, and then in this case x is 2. So those are my two solutions to that problem. Okay? Now the next problem, remember, we have to isolate this absolute value first, so we've got to subtract the 5. So now I have absolute value of 2x minus 7 equals 2. Go back to what we did earlier. Let's go ahead and try to write the two different equations. 2x minus 7 equals positive 2. 2x minus 7 equals negative 2. And we're going to go ahead and follow the steps to solve this equation. X is 9 halves, or I could write x is 4.5. Either is appropriate. X would be 5 halves, or I could write x equals 2.5. Either is appropriate there as well. So I'm going to go ahead and leave them as decimals since they're so nice. Okay. So now taking a look at this problem, okay, it's really important that we remember that we're talking about distance here. And in general, distance is always a positive number. So I need to recognize right away that I have a distance equaling a negative number. And distance, in general, is not negative. So I have to stop myself here, and there's nothing during the problem that's going to help me realize that. I have to stop myself and say distance can't be negative. This has no solution. Done. I'm not going to try to split it into two different equations. I'm not going to solve for x. I'm just going to recognize that I have a distance on one side, the absolute value. I have a negative on the other side. And distance cannot be negative. By the way, that's just a little different from this problem. Okay? So in this problem I have to solve for that absolute value first. So I'm going to subtract the 6. And I know some of you might look at that and say, oh, well, it's a negative again. Well, not really. I don't have the absolute value by itself yet. Now that I've isolated the absolute value, I notice that it's equal to a positive number. So I can now split it up into those two different locations and go ahead and solve. So in this case, x is 9/2 again, and in this case, x is actually -7/2. And those would be my answers.